One, two, three, one, two, three. Hopefully everything is working as it does. Shit, it's been a long time. It's been like what, 3 weeks, 4 weeks, 2 weeks, I think. Yeah, maybe. Yeah, welcome back to another stream. Yeah. But yeah, shit, it's been a long time. It's been a long time. As you probably have seen, uh currently having my exam week, so I'm not streaming as much because I want to focus on my exam, but I'm trying to stream um, when I can, basically. Basically, what I said, it's about the quantum mechanic oral exam, which is in next week, and the analytic chemistry exam also. So it's like two days. They're back to back, which is dumb. But yeah, this stream is about submitting my lab report, which I made. Uh, uh, like I made for how many months? How many weeks? I think it was 10 days. Probably. I lost track of everything. Um, but yeah, honestly, oh, how the hell do I do this? Bro, I forgot everything. Oh. But yeah, we hit freaking 123 subscribers, which is pretty amazing. Like we're gaining audience and we're just growing, which is cool. So this is what's keeping me going with motivation, and yeah, I just want this over, man. I hate quantum mechanics so bad, bro. Okay, so I wrote a bit of my lab report. This right here. Basically, the lab report is about a unknown or inorganic compound was which were used IR spectroscopy and UV-vis, so and to identify the compound, which was a fun exercise to be honest in the laboratory, and it was like I read. I have a picture of it in my lab report. Shit, that's not the lab report. That was something else. Uh. Mm, 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 mm. There we go. Can you see this? Yeah. This shit is just for privacy reasons, so that's why I uploaded so you guys can be weirdos. But yeah. So I just need to spectroscopic techniques are important analytical tools in chemistry because they provide information about the composition, structure, and electronic properties of molecules through their interaction with electromagnetic radiation. That's a really good sentence. Since different spectroscopic methods explore different molecular energy levels, they provide complementary information and can be combined to identify unknown compounds with high confidence. In this little thing floating here, it's called a reference, so it just shows where I got this from. And I had like a textbook, so I used the textbook from that. In this laboratory report, the theory behind ultraviolet, UV-vis, and IR spectroscopy is first presented following by the analysis of an unknown inorganic compound labeled UU7. In addition, the spectroscopic properties of the permanganate ion MnO4 MnO4 minus are investigated through UV-vis and IR spectroscopy. Particular attention is given to the relationship between electronic transitions, vibrational structures, and molecular symmetry. The results are discussed and evaluated with respect to the reliability of these spectroscopic assignments, possible sources of errors, and agreement with literature values. Finally, a conclusion is presented which summarizes the identification of UU7. The purpose of the experiment was to demonstrate how spectroscopic techniques can be used to identify unknown inorganic compounds. An unknown inorganic compound labeled U7 was characterized using IR and UV spectroscopy. The experimental spectra were compared with reference spectra and literature data to determine both the transition metal containing species and counter ion. UU7 consists of an aqua complex containing one of the transition metal ions, manganese, cobalt, nickel, uh, copper, copper, together with one of the possible counter ions. Okay, IR spectroscopy was used primarily to identify the anion through its characteristic vibrational frequencies, while UV spectroscopy was used to investigate electronic transition associated with the transition metal ion and help its identification. In addition, the absorption spectrum of manganese ion, permanganese ion, was analyzed to examine the relationship between electronic transition. I did already say that, right? Mm, the molecular absorptivity coefficient and absorption maximum of permanganese were determined experimentally and compared with literature values. UV spectroscopy in inorganic chemistry. UV spectroscopy is an electron spectroscopic technique that measures the absorption of ultraviolet and visible radiation by atoms, ions, and molecules. The UV region typically covers wavelength from approximately 200 to 800 nanometers and provides information about electronic transitions between molecular or atomic energy levels. When electromagnetic radiation is absorbed, electrons are promoted from lower energy states to higher energy states, producing characteristic absorption bands that can be used for qualitative and quantitative analysis. In inorganic chemistry, UV spectroscopy is particularly useful for studying transition metal compounds because many transition metal ions absorb radiation in the visible region of the electromagnetic spectrum and therefore appear colored. The observed color arises because specific wavelengths of visible light are absorbed while the remaining wavelengths are transmitted or reflected. As a result, the color observed is complementary to the color absorbed. Figure 1 illustrates the relationship between absorbed and observed colors. For example, absorption of light in the green region approximately 490, 500, yeah, causes the color to appear red, whereas the absorption of the value, okay, the color of the solution can therefore gather information about the position of its absorption band and the identity of the absorbent species. Okay. And then we have the color wheel, which is the first figure of the lab report. Colors of transition metal can arise from electronic transition involving the metal d orbitals. In a isolated metal ion, the 5d orbitals possess the same energy. However, when ligands such as water molecules surround the metal ion to form a coordination complex, electrostatic interaction between the ligands and metal ion remove this degeneracy. Yeah, okay. Anyway, where was I? The middle d orbitals. Okay. Degeneracy, this phenomenon is known as crystal field splitting, results in the formation of a group of d orbitals with different energies. When visible light is absorbed, an electron. Therefore, different metal ions absorb different wavelengths of light and display different colors. Yeah. Yep. Uh, figure two. Yep. This is the yep. Solutions are yellow. These differences originate from variation in electronic structure and crystal field splitting. Although color alone cannot be used for definitive identification, it provides valuable information that can be combined with spectroscopic measurement for reliable characterization for unknown inorganic compounds. The intensity of absorption in UV spectroscopy is described by the Muir-Lambert law, where A is the uh, absorbance. E is the mole, or epsilon is the molar absorptivity coefficient, and C is the concentration of. Oh, can you? Who's sending me messages, bro? Did my number get leaked? Anyway. Okay, so this is the UBVs in inorganic chemistry section. So a bit of theory, and then we have the IR spectroscopy in inorganic chemistry. So yeah, just a little theory about that. There's the reference IR spectra of the selected inorganic salts, which was these anions. and they're containing those anions, which are good to identify what the compound holds, basically. Then we have the experimental methods, and yeah, it's just a bit of that, how the procedure was, how we basically did the experiment, and then the potassium permanganese reference measurement. Yeah. But yeah, I spent what, about 7 days of writing all of this. Yeah. So now I have both. I have to submit both lab report on of 11 June, and I'm gonna do it when I know it's 100% complete. Um, some reference measurements. So this was the compound, basically. I don't know if you can see it. It's like a red crystallic inorganic compound. But yeah, honestly, it was a fun exercise. Like, if it was a fun laboratory exercise, because you felt like a detective to identify what the hell this is. Yeah, so it's hydrated cobalt 2 nitrate crystals. That's the, yeah. So the unknown compound UU7, I don't know if you can see the whole text, maybe I should. Okay, so the unknown compound UU7 was identified as hydrated cobalt 2 nitrate. So this one right here. Based on the combined UVs and IR spectroscopic evidence, the compound was supplied as red-pink crystals as shown in figure 4, which is consistent with the characteristic appearance of hydrated cobalt 2 salts. The observed color originates from electronic DD transitions, which within the cobalt 2 ion when coordinated by water molecules. So this figure 5, which shows the structure of hydrated cobalt 2 nitrate, which also showing its ion coordinated by 6 water molecules. Okay, so in aqueous solution and in many hydrated crystalline forms, cobalt 2 exists as a hexa-aqua cobalt 2 complex. In this complex, 6 water molecules coordinate to the cobalt ion in approximately octahedral geometry. The positive charge of the complex is balanced by 2 nitrate ions, giving the overall composition of this. The nitrate is a trigonal planar ion, so a bit of Vesper theory for you. Consists of 1 nitrogen atom bonded to 3 oxygen atoms. Due to resonance, the negative charge is delocalized over 3 oxygen atoms, making it all NO bonds equivalent. This delocalization contributes to the characteristic nitrate absorption observed in the IR spectrum near 1,325 centimeter in -1st and 818. Cobalt 2 nitrate is highly soluble in water and is commonly used as source of cobalt 2 ions in inorganic synthesis, coordination chemistry, catalyst preparation, pigments, aromatics, and battery materials research. So a lot of things you can use this shit. Because cobalt readily forms coordination complexes like cobalt 2 nitrate is frequent. Yeah, cobalt 2 nitrate is frequently used as a precursor for preparing cobalt-containing crystals and cobalt oxide materials. So a bit of what you can use this, or what do they use this for? So there's a reference right here. Yeah, so basically the identification of UU7 was a hydrated cobalt 2 nitrate. So thanks for UVVis. Oh, it's right here. Yeah, basically. So this is the graph we got. So the green is nitric acid, and the yellow is the unknown compound, U7. Figure 5, right? Yeah, okay. So figure 6 shows the experimental UV spectrum of U7s dissolved in 1.100 mole nitric acid. The spectrum show a broad absorption band with the maximum at approximately 515 nanometers. As mentioned in the theory section, then I like to complete with the theory section, so it's like a thread going on, so it all makes sense, just like Attack on Titan. UV spectroscopy measures the absorption of ultraviolet and visible light associated with electronic transition within ions and molecules. In transition metal complexes, these absorptions are commonly related to DD transitions or charge transfer transitions, and the position of the absorption band can therefore be used to identify the transition metal ion that is present. As described in the theory section, like I did again. So I just observe what the color mean, blah blah blah. So the experimentally determined lambda max was compared with later values and for the possible transition metal aqua complex provided in the laboratory. So this basically we had this, and it gave us a nanometer of 515, which was cobalt. So right here, easy. So yeah, like I said, it was pretty fun exercise, and all this writing shit is just the unfun part of it. Uh, yeah. There's a little bit of UV's analysis of potassium permanganate. Uh, yeah, it's a bit of calculation. Hopefully I got this right. 5 515. So it's jumping from here to here. Alright, gotcha. Yeah, so a bit of mathematics. So the original, so all this math basically. Yeah, a bit of mathematics. And then I got a lambda max of 528 nanometers, and absorptions of this is too high, so I subtracted the water blank from the D2 absorbance, which I got this beautiful number. And then I used Lambda's law to calculate epsilon, and it gave me an epsilon of 2,400 ish, 57, 75. So yeah, that's pretty good because the literal value said 2400. So it's good. Yeah, and this one is too high. Then I just showed what will happen if you use this instead. It's too high. Yeah, so I got these values, which was, I'm pretty much satisfied. I don't know what's going on here. It's like a party going on here without my invite. So what the hell? Okay, probably the word online is doing something funny. Infrared, same, just the analysis of the infrared spectroscopy. So this one is corresponding to OH group. This one is corresponding to water molecules, and these one are matching nitrate right here. These right here. This has, yeah, this matches. It has a peak on 818. It has a peak on 824. So it's basically the same, and that's why we got nitrate on this. So yeah, that was pretty fun. It's like you're playing detective, so it was a pretty fun exercise. Yeah, then I just explain it has in this one you can see that, in this one you can see this, why, because this, blah blah blah. Yeah, a little table I made. Ooh. Yeah, so a little bit of IR. Then we have the discussion. So basically, just some questions I had to answer in the lab report, which were crucial because then I couldn't get graded. Crucial, crucial, yeah, crucial. Um, yep, that's fine. The identification of the counter ion was achieved using IR spectroscopy, as mentioned in the previous session. Figure 10. What the hell is going on here? And here, this is like a party going on. And then some reference spectra of permanganate and chloride, perchlorate, because they basically look the same and they have the same molecular geometry. So that was also one of the questions. And then we have sources of errors. What can happen? Like what errors could affect this shit? Yep. Conclusion, basically. So let me read it out for you aloud so you can see what the hell we got to, or I got to basically. The unknown inorganic compound U7 was successfully identified using a combination of UV and IR spectroscopy. The UV spectrum exhibits a broad absorption band with a maximum at approximately 515 nanometers, which matched visual values for the hexa aqua cobalt 2 complex, leading to the identification of cobalt 2 as the metal ion. The IR spectrum displayed characteristic nitrate absorption at 1000, yeah, okay, confirming the presence of nitrate as the counter ion. In addition, broad OH stretching and high water bending vibration demonstrated that the compound contained water and was therefore hydrated. The spectroscopic results from UV and IR spectroscopy were consistent and identified UU7 as a hydrated cobalt 2 nitrate salt. Furthermore, analysis of the permanganate ion demonstrated the difference between weak DD transitions and intense LMCT transitions. The experimentally determined values of lambda max was 528 nanometers and epsilon on 2400 for permanganate were found to be good agreement with literature values. Overall, the experiment demonstrated how complementary spectroscopic techniques can be used to identify unknown inorganic compounds and provide insight into both their electronic and vibrational properties. Come on, that's a really good conclusion. That conclusion gives like makes me wet. That's so good. Okay. Um. Yeah. So basically, it's my biography, all my sources I got. So that's good. That's good. Everything is good. Yeah. So basically, the plan is to work, work. Yeah. I mean, it looks fine to me. I don't think there's any more errors in the freaking report. But yeah, honestly, guys, I miss you. Miss you so much, and I've been working on my website too. So more. Why can I exit live chat? There we go. But yeah, I miss you guys so much. Like, let me actually show you something that is getting worked on, which is pretty cool. What the hell? Wait. Can you see this? Yeah. Basically, we developed a compound lookup. So basically, by the power of PubChem, you can basically write anything like any compound you want to look up, and it will give everything. So testosterone, I can't spell for shit, but it still got it. So it will basically give you everything about testosterone and molecular weight. And for my medical chemists, we have H bond donors, H bond acceptors, and Lipinski rule of five. So if it's orable, like if it can be taken oral, orability, is that a thing? But yeah, it's pretty cool. So I really love it since it's really relevant to my major. And other tools, honestly, we just developed. Yeah, can you be more loud? Let me show you guys. There we go. So yeah, we have like a toolbar, so it's easy to navigate. So we have learn, periodic table. What else? Oh yeah, we have new chemistry games also. We have geometry rush, color challenge, nomenclature, mystery salt for inorganic, and then we have reaction type, an isotope game, and a core reactor. So yeah, a lot of games coming up. So stay tuned for that. And then we have what else did we develop? Oh yeah, this one orbital visualizer. This still is in development. So you can see what orbital you can get, some quantum mechanics stuff. So in 1s orbitals looks like this, then you have the quantum numbers and everything. So that's pretty cool. What else do we have? What else? But yeah, honestly, stay tuned for more updates on the site because there's gonna be a lot coming. Equation balancer, unit converter, I think you saw it. Daily challenges, mechanisms. I think you also saw a molecule drawer. Oh yeah, a molecule drawer. So you can basically like draw molecules. So and it also give you a molecule formula down below. So let me draw 1, 2, 3, 4. Let me draw butanol. Okay, why the hell do I have to add the separate? Oh yeah, there we go. So there we go. Then I create it, and then also count what atoms and bonds and elements. Hi, live after so long. Anyways, I had class, so I'm joining late. I'm not home right now, so if you still live like after 20 minutes, I'll join. I'll be live tomorrow. Don't worry, man. I will be live tomorrow. But today is gonna be a little short stream because I have things to do. So no problem. You can just join tomorrow if you want. I'm just showing showing. But yeah, I appreciate you being in the chat, Sogosh. You're the goat. What else? Reaction search, so you can search up reactions problems. So yeah, like problems you can practice on. And MSD sheets, so what is dangerous, what is not dangerous. So that's pretty cool. So it have everything you have. But it's also good to access the official thing. So this is still, yeah, in development. Nomenclature, so you can search of what the hell this is named. Still in development. Forums. Oh yeah, we developed a new forum site, so you can. Okay, this is. So you can create a post. Like you can just say test or like help or first forum page, and then you can submit your content. This is pretty sick. Post, sorry, post. So you can, if you need some help with questions, then you can just submit it here or in my Discord server. Doesn't matter. Then I will help you here, and you can also input an image. So you can say post, and it should be post. Okay, never mind. So yeah, it's right here. This still needs work, so what else do we have? Terminants. There's terminants. So chemistry terminants. That's gonna be cool. And achievements, duels. This one is my favorite because then you can battle online people to chemistry duels and play along together. And yeah. And then we have study groups and yeah, so AI study plan and problems. So a lot of things coming. This is just something we're working on. And then there's the home site. This is pretty cool. But yeah, we're definitely implementing a lot of things. So yeah, expect more from Xenium.net. So yeah, I'm glad I got the chance to stream again. I miss you guys so much. And yeah, tomorrow it's gonna be a freaking what the hell? Tomorrow it's gonna be a quantum mechanics or practice stream. And hopefully also submitting my lab report also. So it's gonna be a really good stream. Hopefully I will get everything done. And yeah, I'll see you tomorrow. Honestly, it's gonna be good. But if I don't stream tomorrow, then I probably can I stop? Then I probably like is really stressed or something. But I'll try my best to stream tomorrow. Don't worry. And my barber really messed up my hair, bro. He really cut it so short. Bro, can you stop? Someone is sending me messages. I don't know who it is. Yeah, sure. All right. Yeah. But yeah. Did you have the quantum mechanics exam or is still preparing? Like I said, my quantum mechanics exam is in next week, so I have to prepare 14 freaking questions. And I'm still preparing. But I'm gonna be preparing with my chat. But yeah, I'm still preparing. And yeah, I'm also oh yeah, the marathon actually the marathon sent me a like there was a lottery between if you can get a ticket to the marathon in next year, and I just submitted my lottery like hoping for it. I was getting picked, and I got picked. So that officially means I'm gonna be participating a 2027 marathon. So basically, in the whole summer vacation that is coming, I am definitely gonna lock the frick in with my running training and oral training also. But I'm gonna try my best to stream it all. And like I said, this is just a project for myself. So yeah, just like show people that I'm not only with chemistry, I'm also like other things. But the most part of this channel is chemistry, so since I like chemistry. Okay, so but I appreciate you, Sogosh. Thank you for popping up in the chat like you always do. You really makes my day and keep me motivated to stream. And yeah, eat well, stay hydrated. I'll see you tomorrow. And they're still texting me, bro. Can you please let me stream, bro?